Hi everyone. In this video we're going to be working on 2015 AP Calculus BC Free Response question number 6. Now this was the most difficult question that occurred on the 2015 exam, so let's go ahead and get started. This is the Maclaurin series for a function f is given by the summation from 1 to infinity of that equation, which equals the function x minus 3 halves x squared. That's very important to understand that this right here represents the function. So I would want you to put f of x right there, because that's if you would expand it, that's what you would get. Now, don't forget, Maclaurin series is when x is equal to 0 if you're writing it out as an equation. Then it says, and converges to f of x for absolute value of x less than r, where r is the radius of convergence of the Maclaurin series. So when you read this, you should think about everything that you did in that chapter, all the tests that you had, but now as of right now, we're just working with the Maclaurin series, and it's telling us it's going to converge with r as a radius. Part A says, use the ratio test to find r. Well, we got to remember ratio test. Ratio test was when we put n plus 1 over the original sum. So we're going to say, okay, well, let's plug in n plus 1 to every single n that we see. So it's going to be negative 3, n plus 1 minus 1, so hopefully you can read it's n, times x to the n plus 1 over parentheses n plus 1. All being divided by the original, which is negative 3 n minus 1 times x to the n over n. Now, this is the part where we have to do the limit as n goes to infinity. So our first thing is we have to split this up. So we're going to work this out a little bit. This is technically a fraction over a fraction, which means that we're going to have to keep change flip. So when we keep change flip, you should get something that looks like a little like this. Negative 3 to the n times, and I want you to separate this, x to the n times x all over n plus 1, multiply, and don't forget the absolute value at the end, and then you're going to flip the bottom fraction, which is going to be n on top over, and I want you to separate this as well, negative 3n times negative 3 to the first times x to the n. Now this is the part where you're going to have to cancel out a lot of like terms. For example, this is gone. This is gone. X to the n is gone. X is gone. And the only thing we're left with, and my biggest mistake so far, is when I separated this one, I had to put minus 1. So my next thing is I'm going to rearrange things, fix things up a little bit. I'm left with x, n plus 1, and 3 to negative 1. But you got to remember this 3 to negative 1 since is going to go up. So this is become this. Negative 3 times x times n over n plus 1. And don't forget the limit as n goes to infinity on the outside. So the next thing is you're taught is you want to separate everything that has an x to the right or to the left, doesn't really matter, and you want to separate all the n's. And keep the numbers with the n's. So then this is what it's going to become. Limit as n approaches infinity of negative 3 n over n plus 1 times absolute value of x. Now the reason why I separate it is because n going to infinity is going to be this, and I can find the limit of this. And because n is going to infinity, this is your HA rules, where whenever you have the same exponent is 1 on top, exponent is 1 on the bottom, you're just going to simplify this, and this should give you an answer of 3. Because the absolute value of negative 3 would be positive 3, and then this will just leave you as absolute value of x, and that's our equation. Now we have to remember one thing. If this is going to converge using the ratio test, and you have to remember this, the ratio test only converges when it's less than 1. So our next thing is we have to solve for that, and inside of here is going to be the radius of convergence, and when we simplify that, this is going to give us this. Absolute value of x is less than 1/3. So that means that the radius of convergence is r equals to 1/3. Why? This is the value that you get. Okay? So don't forget how to apply the ratio test. The ratio test is putting n plus 1 into your first term and then putting it over your original. And then you have to keep change flip, and when you keep change flip, separate everything that can be separated because it's going to cancel out. Then separate all your n's with the numbers and separate your x's. and then simplify and know that the only reason it converges is if it's less than 1, solve for x, and that's going to be the radius of convergence. So then we're going to move on to part B. Part B says write the first 4 non-zero terms of the Maclaurin series for f prime, the derivative of f, express f as a rational function of absolute value of x is less than r. So the first thing, let's find the first 4 non-zero terms for f prime. Well, we have to think about, well, what is f of x? And let's not think way too hard about this, because remember, we said that f of x is the original equation for this. So all they want us to do is find the first 4 derivatives. So this is the first, this is the second, this is the third, and we're missing the fourth. Well, don't forget, I can find the fourth by plugging in 4 into n. So that's going to be, and this is the work I'm going to put up here, negative 3 to the 4 minus 1, which is 3, times x to the n, which is 4, over n, which is 4. So this is going to simplify to negative 27, x to the 4 over 4. So they want us to find the first 4 derivatives. So for part B, my first derivative of x is just 1. So f prime of x thus far is 1. The derivative of negative 3 halves x squared, bring the 2 to the front, 2's cancel out, so you're left with minus 3x. Then your third derivative is going to be the same thing. Take the 3 to the front, plus 9x squared. And then your fourth derivative, bring 4 to the front, is going to cancel out, negative 27x cubed. And that's what they were looking for. Then it says express f prime as a rational function of absolute value of x less than r. This is the part where it was a little bit of critical thinking that we needed. We need to express this as a rational function. But this is what you have to ask yourself. When is the only time in series that we were able to kind of separate things and make it a rational function? Hopefully you thought when you had to find the summation of a geometric series, which a geometric series, the summation of it was a over 1 minus r, where a is the first term, r is the ratio. Well, think about it. What is our ratio here? Our ratio, everything's being multiplied by technically negative 3x to a power. What do I mean by that? Well, remember, plug in 0. Negative 3x to 0 is going to give you 1. Negative 3x to the first gives you that. Negative 3x to the squared gives you that. Negative 3x cubed gives you that. So that's my ratio. Well, what's my r? 1. So then what we're going to do is plug it in. This is 1, so it's going to be 1 over 1 minus your r, which is your ratio, negative 3x. Simplify this, 1 over 1 plus 3x. And that's my rational function. So, then we move on to part C. Part C says, and this is our last part, and this was worth 3 points, by the way. So, as of right now, when we did part A and part B, that was worth 6 points, which is good because the average on this was very low in 2014. So now we have 3 more points, and it says, write the first 4 non-zero terms of Maclaurin series for e to the x. And you have to remember, Maclaurin series, what does that mean? That means that your value is going to be 0. Well, remember, how do we find series? This is one that you should kind of remember because e to the x is the same as when you do f prime, f double prime, you're going to get the same value. But a Maclaurin series, and they're saying for the first 4 non-zero, so they want you to do f of 0 plus f prime of 0, x minus 0 to the first over 1 factorial, plus f double prime of 0, x minus 0 squared over 2 factorial, plus, last one, f triple prime of 0, x minus 0 cubed over 3 factorial. So those are your first 4 terms. So what we have to figure out is the derivative. Well, don't forget, if you find the first derivative of e to the x, f prime of x is going to equal to e to the x, f double prime of x is going to equal to e to the x, f triple prime of x is going to equal to e to the x, and you can keep on going, it's still going to be the same thing. So if I were to plug in f of my Maclaurin series, which is 0, I'm going to get 0, 0, 0, all for the exponent, which means e to the 0 is going to be 1, f prime of 0 is going to be 1, dot, 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 they're all going to equal to 1, which is why this is one of those that you should just kind of know and understand. And that means that when we plug everything in, our value for f of 0 is 1, plus f prime of 0, which we said was 1, parentheses x minus 0, so we can just say it's x, over 1 factorial, which is 1, plus f double prime of 0, which we also said was 1, x squared over 2 factorial, which is 2, f triple prime once more is 1, x cubed over 3 factorial, which is, remember, 3 factorial, 3 times 2 times 1, which is going to be 6. And if I were to rework this, I'm going to get this. 1 plus x squared over 2 plus x cubed over 6. And that's going to be my answer. So then the last part for part C says, use the Maclaurin series for e to the x, which is the one we just found, to write the third degree polynomial for g of x, where e of x times f of x about x equals 0. And then that was probably the most confusing part. That was where 2 points, your final 2 points, your Taylor polynomial. So this is the thing you have to think about. Well, I already know this, and I'm going to write this on a different sheet of paper. We know as of right now, we have the Maclaurin series for e to the x is 1 plus x squared over 2 plus x cubed over 6. And they want me to multiply it to write the third degree Taylor polynomial. So they want me to multiply this with what I had before, which is f of x. So it's x minus 3 halves x squared plus 3x cubed. And I could keep on going, but the thing is they only want 3, so that's all I'm going to have. Now my next thing is I have to figure out how to actually work this out. Now this is the toughest part. We need to actually multiply this out. So since they asked us third degree Taylor polynomial, this is going to be your first degree plus your second degree plus your third degree. And we have to figure out the numbers that when we multiply this is going to fall under x1. So think about it. What numbers can we multiply in here and here that's going to give us x to the first power? The only number that you should actually see is when we multiply 1 times x to give you 1x. So the only number that we can actually put in here is 1. Now the next number is we want to get anything that can multiply to x squared. And we want to put those coefficients in front. So 1 times x is going to be x to the first, so it can't go into x squared. 1 times negative 3 halves x squared was going to give me negative 3 halves. And then also x times x is going to add up to give me x squared, so that 1 times 1 is going to be 1, and I'm going to put 1 in there. Then the next thing I have to do is I have to figure out all the terms that I can multiply to give me x cubed. So I'm going to do 1 times x, no, it's not going to fit. 1 times x squared, no, it's not going to fit because I'm looking for x cubed. 1 times 3x cubed is going to be 3, so I'm going to put that 3 in the front, and I'm going to keep going. X times x is x squared, no, x times x squared is x cubed, so 1 times negative 3 halves is negative 3 halves. Then you can keep on going, and the final one that we can actually work with is 1 half x squared times x, which is going to be plus 1 half. So then the next thing, and one thing you're also going to notice is, look, you had 1 degree here, I was only have 1 number. You had second degree, we have 2 numbers. You had third degrees, you had 3 numbers. Look for those patterns. This was a tricky question and was the last question that you had on your entire AP exam. So it's one of those where you wanted to be careful, and a lot of people didn't even have time to finish this question. So once you have that, just combine like terms. This is going to be 1x plus combine like terms here, and this is going to end up subtracting to give you negative 1 half x squared. And then when you combine like terms here, this is going to combine to give you plus 2x cubed. And those are going to be your first 3 terms of a Taylor polynomial of your third degree Taylor polynomial when g of x equals to e to the x times f of x about x equals 0. And that was part C. So a lot of part of the question is things you know how to do based off series, and then there's always going to be that one part where it's going to challenge you. Just think about it and sit through it. And I want to thank you guys for watching my video. Hopefully it helped, and let me know how it went.